And my class ID is 3. So here is the ICP2 of Spark Programming Module 2. So we have given uh, two, two of the tasks, MergeSort and DFS. So in the MergeSort here, I have created an object MergeSort and I have defined the main method here. In the main method, I have created a Spark configuration and set the name as MergeSort and the master to local. So I have created a Spark context here from the configuration. So I have created an array of, of some numbers uh, uh, to which I need to sort them sort using MergeSort. And this is just some basic, like I have parallelized A and I have used map array and I sorted it by key. So if you want, I can just print the parallelized array. So here I'm gonna run the general parallelized array. So here I have sorted the array uh, using the sort. So it's just for basic understanding. So here is the merge sort. So here I have taken the length of a in n and I have created a start point as 0 and the end point as r. As the array star index should be less than 1, so I have subtracted 1 from the length of a. So here is the function merge sort. I'm sorting the array a from its starting index and the highest index, and then printing all the elements of a. So here's the function merge sort. It takes the input array and the start and the end index. So here first it will check if the start index is less than the end index. So I am taking a middle value as start plus end by 2. It will give us the middle value. By using the middle value, we'll sort the left hand side array and right hand side array. Later we'll merge those two arrays using the merge function. So here is the function for merge. The merge takes an int. It takes the starting, middle and end. So here I have created two values n1 and n2. They are the sizes of the two subarrays, the left subarray and the right subarray. So for the left subarray, it's middle minus the start plus 1. So the that will give you the size of the left one. Here the size of the right one is last minus middle element, the indexes. So here I have created two integer arrays. One is for left, and the other is for right. So here I have taken a counter as a, just say. So as a is 0, while a is less than n1, that is the size of left subarray, it will get added into the left array. So the basically I'm just copying the uh, elements which are less than the middle element into the array L, and elements which are greater than the middle element into array R. So that's what the code here is. So later, after copying that, I have given two uh, values. I have taken two values I and j which are initialized as 0. That is the initial index of the merge subarray. So here I have taken the value of k also as 0. So when the as I value and j value are obviously less than n1 and n2 here, it will enter into this loop, and if the first element of the left subarray is less than the first element of right subarray, we'll keep the left subarray element into the main array, like the merged array. Like after when while we merge the left and right subarrays, we'll just compare the first elements of the left and right. If the left element of the array is smaller, we'll put first the left element into the array. Else, if the right element is bigger, we'll put the right element into the array. And here we'll increase the counter of the left element as it's smaller. Here we'll increase the counter of right array. So after everything is done, if there are some elements remaining in the left subarray, here we are adding those elements into the uh, merge array. If there are any elements present in the right subarray, here we are adding them into the right subarray. So we'll just execute this, and here we'll get the output. So here is the output. As you can see, it's all sorted. So that's it with the merge sort. And here the next task which we were given was the DFS. So in DFS I have created an object DFS. I have created a main class here, and I have set the properties as Hadoop home directory. I have created a configuration and set the name of it as depth first and master as local. So here I have created a Spark context with the same config. So I have taken a variable v of type int, and I have taken a graph, like a variable graph of type map, and map has the key as int and the values as list of integers. So here I have created a value g of type graph. So the graph takes the type as map. So here we have created a map. This map shows the tree which we need to traverse. So it's like this. This is the main node, root node. 2, 3, 5 are its children, and uh, from 2, uh, 2 has the child nodes as 1, 3, 6. 3 has child nodes of 3, 4, and 4 has the child nodes as 1, 3. 5 has the child nodes of 1, 6, and 6 has the child nodes as 1, 2. So it's not like a tree, it's like a graph. So it's similar to a tree. So here is the function for DFS. The DFS, this function takes two inputs, the start as with the type int, and the graph with the type and the g with type graph, and it gives the output as list. So the output of the list value. So here is the code for the DFS. Inside this function, I have created a nested function of DFS0. In that, it takes the input as input of a type int, and a list called, I have created a list called visited, so that I can mark the list. I can just mark the list if it's visited, we don't need to visit it again. So here it gives the output in the form of a list. So the DFS of 0 takes the elements present in a list as input, and the DFS takes the elements of the map. So here DFS of 0, if the visitor has, this one has V, that is, this list has the element, then it's marked as visited. So if it doesn't have the integer, we are creating a list of neighbors, and we keep the element graph, that is, if it's not visited, then it will be present in the neighbors. That is what we have written here. Filter not, that is, if it doesn't contains if the element is not present in visited, we put it in neighbors, and later the neighbors will be fold left. Fold left is a function which is used to traverse the elements from left to right. So we are traversing the elements in the list V, in the list visited, from left to right. We will just pop out the elements from the list and we'll traverse. So the elements in the list are in the form of a stack. So while we pop it out, it's in the form of, we'll pop it out in the form of BA, and we will be putting it in the DFS 0, so it will be executed again. So as it's popping out in reverse order, we'll just reverse the list, and we'll execute the DFS of 0. So we'll put the output in DFS result. So here I am giving the starting index as 3. So I'll just traverse the map. So first we are starting from 3. From 3 it will go into the list of 3 and 4. In 3 and 4, as it's a DFS search, we should go into the depth first. So it will get into the first element of 3 and it will mark it as visited. From 3 it will again go into the 3, as 3 is already visited, it will go here. So it is also already visited into 3, so it will go into the 4. So uh, our list is 3, next it's is 4, so it will go into the 4. From 4 it will go into 1, as it's depth first. From so it's 3 4 1. After, from 1 it will go into 2, it will mark 1 as visited. So 3 4 1 2. From 2 it will go into 1, 1 is already visited, so it will go into 3, 3 is also visited, so it will go into 6, 6 will be marked as visited, so it's 3 4 1 2 6. 6, it already visited 1 and 2, so it will reach the end. So our output will be 3 4 1 2 6. After it so after it's completed 6, it will traverse back here to this one. So as here it's done, so it will traverse back into the here. So as 2 is complete, 3 is also visited, it will go into 5. So here we'll get the output as 5. It will go into the 5 subtree. 1 and 6 are visited, it will traverse back here. It will come back into 1. From 1 it will go back here. So 3 is already done, it will go back to 4. From 4 it will go back into the starting point. So as it reaches the starting point, all the elements from the visited are popped out. So here we'll get the output as this one. So let's just execute this. So this is the output 341265. It matches with the traversal which I have done. So that's it. Thank you.